gradient formula. We're going to talk about a 2-point formula. We're also going to talk about the two different ways to write the equations. One is gradient intercept form, and the other one is general form. So let's quickly go over these things, and I'm hoping that for a lot of this stuff it is just revision. It's a refresh of what we did in previous years. Does anyone know the equation if I have a gradient and a point? Let's put some examples in so you know exactly what I'm talking about. A gradient of -2 and a point of 1, 4. If we know that a linear function has a gradient of -2 and goes through the point 1, 4, how can we work out the equation of that function? Anyone remember? I may well have given it to you in this last lesson as well. Talked about it briefly. Anyone? Alright. The formula is y minus y1 equals m by x minus x1. Where this is your m and this is your point that's in the form of x1, comma, y1. Okay, so that's the bits that you plug into our formula. And so we say, I'm just writing this out. Yeah, I'm not going to have enough room for that. So we just plug those values in. What's y1 from the information given to us?
4.
Yeah, so it's y minus 4. What is m? Minus 2. What is x1? 1. Okay, we're just putting those things in. Then we simplify and get into one of these two forms over here. And so we say, well, who's going to walk me through it? I'm not going to do it. You guys can do this stuff. How can I arrange this into a gradient intercept form, which has got y on one side and everything else on the other side?
+4.
Okay, so I'm going to add 4 to both sides. So well, you tell me what to write.
4, no, equals
Yep.
4 minus 2, bracket x minus 1.
Okay, that's all right. What's next?
Expand.
Yep.
4 minus 2x plus 1.
Plus
2. Plus 2, right?
2. Yep. Yep.
And
This is the easy part. What do we do now? What's left to do?
plus b.
We've got a 4 and 2.
Like terms.
Yeah, like terms. Yeah, so what do we write?
Y equals -2x plus 6.
Awesome. That's fantastic. That is gradient intercept form. Okay, where we have y equals mx plus b. So we're going to have a y by itself as a positive pronumeral, and we have the x term multiplied by the gradient, and we have a constant term, that's just a number term on the end, can be plus, can be minus, in this case it is plus. It also tells us what is the y-intercept. Okay, it's really easy to draw a line, to actually do a graphical representation of that function using that gradient intercept form. Because we know exactly where the y-intercept is, now it's positive 6. So if I were to draw that, it's going to go through positive 6 up here, and a gradient of -2, so it's going to go down like this, and we can work out pretty quickly where it's going to cut the x-axis. It's going down 2 for every one to the right. Anyone tell me where it's going to cut the x-axis? At 3? Yep. It's going to go down 6 So if it goes down 2 across 1, it's going to go down 6 across 3. So that's our line of that equation. How do we write it in general form though? What is the general form of an equation? It's like this. AX plus BY plus C equals 0. And what do you need? You need A, B and C must be integers, must be whole numbers, and A must be positive. So you've got to rearrange it. You've got to rearrange it in such a way that A, B and C are whole numbers and that A is positive. So let's rearrange this one, the same form, let's write it into a general form. It means putting everything onto one side of the equation. The X term must be a positive and everything must be whole numbers, no fractions involved. Okay, we've already got no fractions, that's easy for us. Let's push that 2x onto this side and the x onto this side, and so it becomes a positive 2x plus y minus 6 equals 0. That's the general form. Everything on one side, all of the coefficients and the constant term are all whole numbers, and the x coefficient, the AE, must be positive as well. It's a really easy thing to look at from here as well then to work out what our gradient is. From a general form, that's just a little formula to remember. Negative A over B. In this case, negative 2 over 1 is negative 2. We already worked that out, didn't we? Our gradient was negative 2, but we were told that for this question. Any questions about using point gradient form? Okay, because we can also use 2 points. I want to write this out. Catch it up in the video later. You can get it all. We can also use 2-point form. Does anyone remember this one? What this formula is? Yeah, so I write that on the right hand side. Yep.
And then over backwards to max.
Yep. So what's on this side? No. It's actually it's a really kind of symmetrical formula. We have the same pattern. Y minus y1 over x minus x1, y2 minus y1 over x2 minus x1. Okay, it's a really symmetrical pattern. It kind of just rolls the tongue, as you're saying. And so we have two points. What's my example here? I had 2 points of 3, 1 and negative 2, negative 8. Yep. 3, 1, negative 2, negative 8. And so it's going to say x1, y1, x2, y2. Okay, so it's really helpful just to label them as you're doing it to make sure you don't get them mixed up. If you're using this as point number 2 and this is point number 1, but then halfway through you switch them around, you'll end up with the wrong answer. Okay, you've got to make sure you're consistent all the way through. It doesn't matter which one you choose, you're just consistent all the way through your working. So it's good to label it. I'd label like that. So let's just plug it in again. So Isaac, what do we start writing?
Putting it in.
Yep. So you tell me.
So y minus 1
Yep.
over x minus 3
Awesome.
equals negative 8
Yep.
minus 1
Yep.
over negative 2 minus 3.
Awesome. Okay. So just plugging the values in. Let's start to do some simplifying. You will have always on this side some simplifying to do because we've got 2 numbers here. Over on the left hand side we have the y and the x. Let's simplify this side. What can we simplify the the right hand side to, Danny?
Is it? Negative 8 minus 1.
Is
I
No, it is. It was 9. It was negative 9. Yeah.
Okay. And over 4. Sorry, not 4. 6.
Even 5. Somewhere in the middle there. Negative 2 minus 3 is negative 5. On the left-hand side, we really can't do anything as yet. Okay, because we've got unlike terms. Y and a number, X and a number, unlike terms. At this point here, the easiest thing to do is to cross multiply. So by that I mean you multiply this bottom one by over here and this bottom one by over here. So if I continue up over here, we have negative 5 y minus 1 equals negative 9 x minus 3. Okay, just to cross multiply, let's get rid of the fractions and let's work from there. So it's negative 5y plus 5 equals negative 9x minus 27. Now, you're going to ask, what form of the equation am I going for? If the question doesn't ask you, whatever you want. My recommendation is that you use general form, because you end up with nice whole numbers rather than dealing with fractions. You may well end up dealing with fractions, and this question will, if you use gradient intercept form. And it's just sometimes messy if you need to use that information further. So general form is always a nice one. So let's work it as a general form thing. Remember, general form, everything on one side equal to 0 on the other side. Always whole numbers, which you've got, that's great. And making sure the x term is positive. Okay, so at the moment, an x term that's negative. So let's move it to the other side. 9x, the 5y stays where it is, the minus 5y. And now I've got a plus 5 already on that side, but I've got to get this negative 27 onto that side too. So I add 27 to both sides, plus 32 equals 0.
So that's what positive 27.
Oh, it is 2. Good pick up.
Shaking right hand, so.
Minus 22 equals 0. Yeah. What I'm doing. So 9x minus 5y minus 22 equals 0. That's the general form of the function that goes through the points 3, 1 and negative 2 and negative 8. If I needed to write in gradient set form, I can. It will just come with some fractions. We'll leave it for a moment like that. Any questions on using the 2-point form? Okay, now the other thing that is